Now we are going to solve question number 7, which says in an arithmetic progression, the fifth term is equal to 1/3 of the 16th term. The sum of the 15th and the 16th term is equal to 33. Find the sum of the first 10 terms of this progression. As we have to find out sum of first 10 terms, so the formula for sum in arithmetic progression is Sn is equal to n upon 2 2a plus n minus 1 d. So it means that we have n, which is 10, and we need to take out a and d. To find out this a and d, there are two conditions given. That one of the condition is that fifth term is equal to 1/3 of the 16th term. Another is the sum of the fifth term and 16th term is equal to 33. So first of all, we will use these two conditions to find out the values of a and d. It's arithmetic progression, and fifth term of an arithmetic progression is a plus 4d, and 16th term of an arithmetic progression is a plus 15d. Now, first condition is that fifth term is equal to 1/3 of 16th term. So fifth term is a plus 4d, and it is 1/3 of 16th term, which is a plus 15d. Now, we can do cross multiplication. 3a plus 12d is equal to a plus 15d. We'll take this a on this side and 12d on other side. So 3a minus a is 2a. 15d minus 12d is 3d. So we have a is equal to 3d, 3 upon 2d. This is equation 1. We'll use another condition to find out second equation. So according to the second condition, we have the sum of the fifth term and the 16th term is equal to 33. So fifth term is a plus 4d and 16th term is a plus 15d. And the sum of these two terms is equal to 33. So a plus a is 2a plus 19d is equal to 33. Now we will substitute the value of a, which is equation 1. A is equal to 3 upon 2d. So we'll substitute here 3 upon 2d plus 19d is equal to 33. So this 2 and this 2 will be cancelled out, and 3d plus 19d will be 22d, which is equal to 33. So we have d is equal to 33 divided by 22. So it is 3 upon 2. Now we can take out the value of a as well. A is equal to 3 upon 2 into d. So in place of d, we will substitute the value of d as 3 upon 2. So we have a is equal to 9 upon 4. So now we have the value of a as well as value of d. So we can substitute here the values as we have to find out the sum of first 10 terms. So n is 10, 10 upon 2. A is 9 upon 4 plus n minus 1 is 10 minus 1, which is 9, and d is 3 upon 2. So we have here 5. We can cancel it out. 2 ones are 2, 2 twos are 4. So it is 9 upon 2 plus 9 threes are 27, 27 upon 2. So we have here 5 and 9 plus 27 is 36, 36 upon 2, which will be 18. So 5 multiplied by 18 is 90. Part B of this question, it is related to geometric progression. In geometric progression, it's given in a geometric progression, the sum of the first two terms is equal to 16. The sum to infinity is equal to 25. Find the possible values of the first term. As we know that first term is always denoted by A, so we can write here A. They have given two conditions. First is the sum of two terms is equal to 16, and another one is the sum to infinity is equal to 25. So first of all, we'll make the equation with the help of this. The sum of first two terms is equal to 16. First term of the geometric progression is A, and the second term is AR. And the sum of these two terms is equal to 16. Another condition is given. Sum to infinity is equal to 25. So A upon 1 minus R is equal to 25. The formula for sum to infinity is A upon 1 minus R. So with the help of this, we can find out the value of A, which is 25 into 1 minus R. We can take A as common here, and A multiplied by 1 plus R is equal to 16. Now, as we have taken out the value of A here as 25 into 1 minus R, so we can substitute over here 25, 1 minus R, 1 plus R is equal to 16. We can take this 25 to other side, and it will go to the denominator. 1 minus R and 1 plus R will become 1 minus R square. We have used here the identity A minus B, A plus B is equal to A square minus B square. Square of 1 is 1 and square of R is R square. Then we will take the 16 upon 25 on this side and R square on other side, so that we have variable on one side and the numbers on another side. So now if we will solve this, we will be getting 25 minus 16 upon 25 is equal to R square. Then R square is equal to 9 upon 25. As we know that we cannot use calculator in this paper, so you have to be very much careful in doing your working. R is equal to square root of 9 upon 25. So we will be getting two values, plus and minus 3 upon 5. So we have two values of R. One is plus 3 upon 5 and another is minus 3 upon 5. So we'll be taking out two values of A, 25 into 1 minus R. We have A is equal to 25 into 1 minus R. Now we'll substitute the values of R in this. When we will substitute here 3 upon 5, positive 3 upon 5, then we will be getting 25, 5 minus 3 upon 5, so 25 multiplied by 2 upon 5. 5 ones are 5, 5 fives are 25. 10. Now we will substitute value of R as 3 minus 3 upon 5. When we will substitute here minus 3 upon 5, so minus will become plus. So plus 3 upon 5. So we will have 25 into 5 plus 3 upon 5, which means 25 multiplied by 8 upon 5. Then we will cancel out 5 ones are 5, 5 fives are 25. So A is equal to 40. So there are two values of A, 10, and A is equal to 40. In question number 8, A part, it's given that integral of 2 upon 2x plus 3 upon 3x minus 1 upon x dx is equal to ln 2.4. And the limits are given from a till 1, where a is greater than 0. We have to take out the value of a. So first of all, we need to integrate this. And when we will integrate this, we will be getting, as it is 2 upon 2x plus 3. So it will be ln 2x plus 3. Then we have here ln, we have here 3 upon 3x minus 1. So we have here ln, it will be integrated to 3 ln 3x minus 1. Minus 1 upon x will be integrated to ln x. And the limits are from a to 1. So which is equal to ln 2.4. We have to substitute the values. In place of x, we will be substituting a, then another time we will be substituting as 1 with minus sign in between. So we will have ln 2a plus 3 plus ln 3a minus 1 minus ln a, then minus, when 1 will be substituted over here, it will become 2 plus 3, 5. So ln 5, we will substitute 1 here, so it will become 3 minus 1, 2. So it is ln 2. Then minus ln 1, which is equal to ln 2.4. So now we have here ln 2a plus 3 plus ln 3a minus 1 minus ln a, then minus ln 5 minus ln 2, and this is 0. ln 1 is 0 because e power 0 is equal to 1. So ln 1 is 0. So ln 2.4. Now we can write left hand side as a single logarithm. ln 2a plus 3 into 3a minus 1. These two will be multiplied, and these all will be divided. So these will be in the denominator. So a multiplied by 5 multiplied by 2. So that is 10a. Which is equal to ln 2.4. As there is ln on both the sides, so we can cancel out ln. And then we can simplify this. So we'll simplify these two brackets. We'll expand. 2a multiplied by 3a is 6a square. Minus 2a. 3 multiplied by 3a is 9a minus 3 upon 10a is equal to 2.4. So this will become 6a square minus 2a plus 9a will be plus 7a. Minus 3 is equal to 24a. So when we will take this 24a on this side, so it will become minus 17a minus 3 is equal to 0. Then we can do middle term breaking. 6a square minus 18a plus a minus 3 is equal to 0. 6 3s are 18, 18 1s are 18, and 18 minus 1 is 17. So we can take 18 and 1 as factors, and there is minus sign. So with 18, there will be minus sign. Now we will take 6a as common. So a minus 3 plus 1, a minus 3, 6a plus 1, and a minus 3. So 6a plus 1 is equal to 0. A is equal to minus 1 upon 6. A minus 3 is equal to 0. So a is equal to 3. In the question, it is given a is greater than 1. So this value is to be rejected. So a is equal to 3 is the answer. In B part, it's given, B first part, it's given find d 6 sine cube kx upon dx, where k is a constant. It means that we have to differentiate this. When we will differentiate this, we first differentiate the power. So this will become 3 will be multiplied by 6. So it will be 18, and then sine square, and then kx, and then we differentiate this. So when we will differentiate this, we will be left with k, right? So, and then this is to be differentiated. The function is to be differentiated. So this will give as cos kx. So we will have here 18k sine square kx and cos kx. Then in the next part, they are asking, hence find sine square 2x cos 2x dx. As we have already differentiated, when we differentiated 6 sine 3kx, then we have got 18k sine square kx cos kx. So as they have said, hence find this. So first of all, we will write it. When we will integrate this, this will be equal to this, the one which we have already differentiated. So we can write different integral of 18k sine square kx cos kx dx is equal to 6 sine cube kx. If we substitute the value of k as 2, so this will become 18 into 2, 36. 36 sine square 2x cos 2x dx is equal to 6 sine cube 2x. Now, as we have to find the value of sine square, integral of sine square 2x cos 2x dx, so we have to take 36 out of this integral. So 36 integral of sine square 2x cos 2x dx is equal to 6 sine cube 2x. So now we have here sine square 2x cos x 2x dx is equal to 6 upon 36 sine cube 2x. So we have here sine square 2x cos 2x dx is equal to 1 upon 6 sine cube 2x plus 2. In the next question, we have a particle P is traveling in a straight line. Its acceleration A away from a fixed point O at time t is given by A is equal to 3t plus 2 with power minus 1 upon 3, where t is greater than or equal to 0. When t is equal to 2, P is traveling with a velocity of 8 and has a displacement of minus 4.8 from O. Find an expression for the velocity of P at time t. So acceleration is given. If we have to find out velocity, then we have to integrate. Acceleration is given and we have to find out velocity. So velocity will be equal to integral of this acceleration, right? So when we integrate acceleration, we get velocity. So we have to integrate this 3t plus 2 with power minus 1 upon 3. So we have here v is equal to 3t plus 2 with power minus 1 upon 3 plus 1 will be equal to 2 upon 3 plus c, and we have to divide it by the power 2 upon 3 and multiply it by the integral, the differential of this, that is 3. So we have here v is equal to 3t plus 2 with power 2 upon 3 plus c. 3 and 3 would be cancelled out, so we will be left with 2. So we can write here 1 upon 2. So now they have given that when time is 2, P is traveling with a velocity of 8. So with the help of this, we will be taking out the value of C. So velocity is 8, 1 upon 2, and then 3 into 2 plus 2 with power 2 upon 3 plus C. So we have here 8, 1 upon 2. It will be 3 to the 6, 6 plus 2, 8, 8 to the power 2 upon 3. When we will solve this 8 power 2 upon 3, we will be getting as 4. So 4 divided by 2 is 2. So 8 is equal to 2 plus C, and C is equal to 6. So the equation of velocity is equal to 1 upon 2 3t plus 2 with power 2 upon 3 plus 6. Now they are asking, explain why P is never at rest. As we know, the velocity is 1 upon 2, 3t plus 2 with power 2 upon 3 plus 6. And as we know, the time is always greater than 0. So when we will substitute here 0, the velocity will be positive. If we'll take any value greater than 0, we will always get the value of the velocity as greater than 0. So it means that we will never be getting velocity as negative. Means that it will never be at rest, right? So time is greater than 0 and velocity is always greater than 0. So it will never be at rest. In the next part, they are asking find the displacement of P from O when T is equal to 25 upon 3. So as we know that when we will integrate velocity, then we will get displacement. So we have the equation for velocity as 1 upon 2, 3t plus 2 with power 2 upon 3 plus 6. So now if we have to take out displacement, which is represented by S, we have to integrate 1 upon 2 with 3t plus 2 power 2 upon 3 plus 6. So we can write 1 upon 2 outside, right? And then 3t plus 2, we'll add the power 1 plus 1 here. So 2 upon 3 plus 1 would be 5 upon 3. Plus, when 6 will be integrated, it will become 6t. And there is constant d. And this is to be divided by 5 upon 3 and multiplied by 3. This 5 upon 3 will be here, and the differential of it is to be divided by the differential of this bracket. So we have here 3 and 3 would be cancelled out. So 1 upon 10, 3t plus 2, 5 upon 3 plus 6t plus d. Now, to find out this value of d, it's given in the question that it has a displacement of minus 4.2 when the time is 2. So now we will be substituting the value of t as 2 and the value of s as minus 4.8. So we'll substitute the value of s as minus 4.8 and the value of t as 2. Plus 6 into 2 plus d. We have to find out the value of this d for which we have substituted these values. So 3 2s are 6 and 6 plus 2 is 8. 8 with power 5 upon 3 plus 12 plus d. So 8 to the power 5 upon 3 will be equal to, we can write it as 2 power 3. This 3 and this 3 will be cancelled out. So 2 power 5 is 32. 1 upon 10 into 32 plus 12 plus d. We can take this plus 12 on this side, so it will be minus 12 is equal to 32 upon 10 plus d. 32 upon 10 would be 3.2, so it will be minus 4.8 minus 12 minus 3.2 is equal to D. So minus 20 is equal to D. S is equal to 1 upon 10, 3t plus 2 with power 5 upon 3 plus 60 minus 20. So we have got the equation of displacement, that is S. Now they have asked to find out the displacement at t is equal to 25 upon 3. So we have to substitute the value of t as 25 upon 3. So S is equal to 1 upon 10, 3 into 25 upon 3 plus 2 with power 5 upon 3 plus 6 into 25 upon 3 minus 20. So we have here 3 and 3 would be cancelled out. 3 ones are 3, 3 twos are 6 will be cancelled out. So we will be left with 1 upon 10 into 27 with power 5 upon 3 plus 25 twos are 50, 50 minus 20. So here it will be 3 power 5, because you can write 27, 5 upon 3 can be solved as 3 with power 5 upon 3, 3 with power 3, 5 upon 3. So this 3 and this 3 would be cancelled out. So it will be 3 power 5. And 3 power 5 is 243. So 243 divided by 10 and plus 30. So it is 24.3 plus 30, which is equal to 54.3. Question number 10. It is related to coordinate geometry of circle. So it is given a circle has center 2 comma minus 4 and radius 3. The line y is equal to 2x minus 3 intersects the circle at points A and B. The perpendicular bisector of line AB intersects the circle at points X and Y. Find the area of kite AX BY. So this I have added to make it clear for you. Now, first of all, they have said that we have to find out the area of AX BY. For that, we must know the coordinates of A and B. Circle has a center 2 comma minus 4 and radius 3, and the line y is equal to 2x minus 3 intersects the circle at points A and B. So we have to find out the intersection point of a circle with this line. So for that, we need to take out the equation of circle. For equation of circle, it is x minus 2 whole square, as it is center is 2 comma minus 4, plus y plus 4 whole square is equal to 9. The equation, the general form of the equation is x minus a whole square plus y minus b whole square is equal to r square. So we have here a and this is b. So when we substitute here 2, and when we'll substitute here minus 4, so minus minus will become plus. Now we have got this equation of circle. Now we have to solve it simultaneously with this. So there is y value given 2x minus 3. So simply we can substitute here 2x minus 3 plus 2x minus 3 plus 4 whole square is equal to 9. So when we will simplify it, it will become 2x plus 1 whole square is equal to 9. Now we will open it using the identity. So x minus 2 whole square will be equal to x square minus 2 into x into 2. It is minus 4x. 2 square is 4. Then square of 2x is 4x square. Then 2x into 2 into 1 is 4x. Plus square of 1 is 1 is equal to 9. So minus 4x and plus 4x will be cancelled out. We will be getting 5x square is equal to 4x square plus x square is 5x square. 4 plus 1 is 5, and 9 minus 5 is 4. So we have x square is equal to 4 upon 5. And x is equal to plus minus under root 4 upon 5. So we have got two values of x. So we will be getting two values of y as well. So we have x is equal to square root of positive square root of 4 upon 5. And we have x is equal to minus square root of 4 upon 5. So when we will substitute this in this equation, y is equal to 2x minus 3, we will get the value of y. So y is equal to 2 into under root 4 upon 5 minus 3. So we can take out the square root of this numerator, so it will become 2. And 2 multiplied by 2 is 4. So 4 upon under root 5 minus 3 is the value of y. We have here y is equal to 2 into minus under root 4 upon 5 minus 3. Again, we will get here 2. So 2 multiplied by 2 is 4. So minus 4 upon under root 5 minus 3 is the value. So now one of the coordinate is A and another one is B. We can write this as 2 upon under root 5. And we can write this as minus 2 upon under root 5. So the coordinates are of A are 2 upon under root 5, comma, 4 upon under root 5 minus 3. And the coordinates of B are minus 2 upon under root 5, comma, minus 4 upon under root 5 minus 3. Minus 4 upon under root 5 minus 3. We have center as at 2 comma minus 4. So it is 2 and minus 4 is over here. This is the center. And 3 is the radius. The coordinates of A are 2 upon under root 5, comma, 4 upon under root 5 minus 3. And the coordinates of B are minus 2 upon under root 5, comma, minus 4 upon under root 5 minus 3. We can consider A here, and we can consider B over here. So if A and B is over here, they are saying find the area of kite AXBY. Now they are saying the perpendicular bisector of line AB intersects the circle at X and Y. So if we join these 2 points, we will be getting this. And the perpendicular bisector of this line must be like this. Okay, this point we consider as X and this point we consider as Y. So you can see this is forming a kite. So now we have to find out the area of this kite. As we know that this is a perpendicular bisector, so it must be making right angle with here, with this AB. So whenever there is a right angle here, then it means that this, as it is a perpendicular bisector, so these two must be same. As we know that there are two congruent triangles over here. One is this one, another one is this one. So to find out the area of these two triangles, we must have this length, right? And this is the half of AB. And this length is the diameter, right? So we already know that the radius is 3. So the length of XY is 6. So if we'll take out the area of this triangle and we multiply it by 2, we'll be able to get the area of this whole. So first of all, we have to take out the length AB. So AB is equal to under root minus 2x2 minus x1 minus 2 upon under root 5 minus 2 upon under root 5 whole square, then plus minus 4 upon 5, 4 upon under root 5 minus 3 minus 4 upon under root 5 minus 3 and then whole square. Okay, so as under root 5 is same, so we can write it as under root 5 and we can add the numerators minus 4 upon under root 5 whole square, then plus we have here minus 4 upon under root 5 minus 3 minus 4 upon under root 5 plus 3. So this and this would be cancelled out whole square. So which will be equal to, this will become 16 upon 5. This square of minus 4 is 16 and square of under root 5 is 5. Then we have here minus 4 and minus 4 would be minus 8 and minus 8 square is 64 and under root 5 square is 5. So we have here 80 upon 5. So which is equal to under root 16. So AB is equal to 4. And we know XY is equal to 6. So for area of kite, we have 2 multiplied by area of triangle, which has this length as 6 and this height as 2. So 6 into 2. So 2 ones are 2, 2 threes are 6, and then we will have 2 threes are 6 and 6 twos are 12. So 12 unit square is the area.